All right. Hi, everyone. Wow, big room. Thanks for coming. My name is Brad. I work at SmugMug. What I'm going to talk to you today about is how we migrated a specific application from MySQL to DynamoDB. Some observations, anecdotes, and tools we use to get there. Why do you care about these tools? Because I'm going to give them to you. All right. Just in case you missed it on the last slide, my name is still Brad. SmugMug is a platform for hosting, sharing, and selling photos. I don't know how many of you are familiar with it. Our target market is professional and enthusiast photographers, although everyone's welcome. Just some background before we get into this talk further. I'm going to give a little bit of coverage as to what DynamoDB is, one slide of coverage. There's been enough sessions here that I think if people wanted to dive in and get a tutorial, there's been plenty of opportunities to do that otherwise. So, like I said, it will be more covering this process of migrating a specific application off of MySQL onto Dynamo and our observations, anecdotes, and tools. A little bit more background on SmugMug. In web years, we're pretty old. We're a LAMP code base. I think our progression of scaling our business, technically and otherwise, probably mirrors the experience of a lot of people here. We've gone from a few machines in a colo to a lot of machines in different colos through to AWS. Currently have under 200,000 paying customers, millions of daily viewers, billions of photos, and petabytes of storage. We're one of the biggest occupants of S3, and that was sort of our thin wedge into the universe of AWS, and we just keep getting deeper and deeper. So in case anyone hasn't seen our site, that's our top page. This is the page a customer might see when they come in to manage our photos. And we try to make the photo the big part of the experience. This is some of our employees. All right, this is my attempt at humor. This will not be DynamoDB even in a nutshell. It will be DynamoDB in a peapod. Here's the one slide where I'm going to go over it for you. DynamoDB, in case anyone isn't familiar with it yet, is a NoSQL database as a service with provisioned throughput. The model's simple. Tables map to keys, which map to items. Items map to attribute names, map to attributes. Attributes are type value pairs. The operations are the standard CRUD type operations. I think since I'm contextualizing this talk in the basis of MySQL, it's worth noting what isn't going to be in DynamoDB if you're coming from a relational database. So you don't have a standard query language. You don't have a state like cursors or transactions. You don't have a server-side functionality like triggers. So before we go in further as to how DynamoDB helped move something off of MySQL, I think it's worth noting just quickly how we use MySQL at SmugMug, some of the hang-ups we have with it, how we use it, so how it was replaced. First of all, I want to say that MySQL, I think, is maligned quite a bit for some of its deficiencies. This talk is not going to be about maligning MySQL, because I personally am a big open source guy, and I think it's awesome that people can go and download a free open source database and build a business on it. We've been using it since 2003. It's been a trooper for us. I think anyone using a tool at scale is using it in an idiosyncratic manner. We're definitely cut from that cloth. So we're using MySQL as a SQL database, but we're not using it as a relational database. So we're avoiding all of these advanced features that might be beneficial in other scenarios, like joins, foreign keys, views, complex queries. The reason being is that like many of you, we're exploiting caching heavily to deliver performance to our users. Memcache itself is essentially a key value store, so that implies that our data model more or less be seen as a key value store, even in MySQL. So this means in our system, you have an ID, you get a row of data back that's pretty much everything you need in that context of the application. So I think this is commonly referred to as denormalization. I think in our industry, many of our peers are already there in denormalizing. Does everyone know what I mean? Denormalization, normalization, right? The upside there is because we're already using MySQL more or less as a key value store, migrating to something that is explicitly a key value store, NoSQL system, is relatively straightforward for us. I think if you're in a scenario where you're exploiting normalization, it's going to be more difficult. For us, it was more or less a simple migration. Now, the downside with denormalizing, as everyone's aware of, well, I put a question mark, some people don't see it as a downside, is that your logic is in your code, not in your database. So in any case, if MySQL's been such a trooper and it's gotten us from 2003 to 2013, why bother kicking it to the curb? Well, we haven't kicked it to the curb entirely. We're migrating off of it over time. But I think it's a similar story that anyone who comes to an AWS conference will echo. They don't want to do their own ops anymore. They want to stop buying hardware. They've used best practices to get them to the end of the road, and they can't really get any further. So what I want to do now is enumerate some of the specific gripes we've had with MySQL over the years. And the reason I want to do this is because I want to come back later and talk about DynamoDB and actually address whether it fixes our specific gripes. So the first one for SmugMug, because we're an older site, our business has changed over the years, the requirements have changed over the years. We've had scenarios where we've had to engage a lot of offline operations, specifically alter table. Unfortunate, and our users were forgiving of it for a while, but it became a bit of an issue for us to do this continuously. Early on in SmugMug's history, I think the customer base was more or less all North American. Over time, you've got people in Europe and Asia. It's 9 a.m. somewhere, always. So someone is always being impacted in their daily use by taking your database offline. This gripe it's MySQL specific. I do know that other relational databases are not as impactful with regards to offline operations. And of course, every time we take the database down and do an alter table, we're making changes in our code. And because we run PHP, you don't know if it's going to start up again. So we did take some steps internally to help mitigate this and buy us a little runway to keep using MySQL with a little flexibility. I think this is also something that you're going to find people, some of your peers at this conference doing. We introduced the concept of getting a blob column and ensconcing JSON serialized data in it. So this data, we can change the shape and nature of it over time without doing an alter table. That's fine. It did help us avoid some table alter operations. The only issue is currently in MySQL, JSON in a blob column is opaque to the system. Now, I do know that the MariaDB people are following Postgres and making JSON serialized in columns visible to the system. But it's been an issue for us over the years. And MySQL was never intended to be used as a mechanism by which you simply got a blob for an ID. So the next issue for us was concurrency, because we've had load increase over years as our site has become more popular. MySQL can manifest some non-graceful degradation under heavy write load. We've done the common sense thing of shuffling tables and databases around, but it's still a pain in the butt for our ops people. Replication, once again, not ripping on MySQL. I think because MySQL had replication pretty much out of the gate, it's why anyone uses it today. But there are performance issues with it. And because we're so heavily reliant on our cache hierarchy, we get into a difficult situation about reasoning about consistency. Once again, just another big ops headache. And so this dovetails into having more people, more colos, all the space concern related with managing your own database, storage network, yada, yada, yada. Now, what would drive us towards DynamoDB? OK, so like many of you here, you're already an AWS user. You're already hip deep in AWS. So we're in the same situation as you were. We were given to assessing an AWS database with greater weight than something from which we compete with another competing cloud provider, just because we're already hip deep in AWS. So we started looking at Dynamo very early on. I don't know how many of you here have played with it or worked with it. My immediate observations were that probably by design, it's very simple. It has limited key structure, limited data types. The notion of ACID that you're used to in a relational database does not really exist in Dynamo, although it does have some concept of transactions for certain types of operations. Things like query and scan are pretty simple to me, not super interesting. But the one thing that struck me immediately is all of these space constraints I've been talking about, like servers, the disk is full, the ops guy is driving a machine out to a colo or something. All these space constraints we'd be freed from because it's presented to the user as an arbitrarily scalable service. I was a little surprised to find out some of the time constraints, though, and I think that's going to be the crux of what I want to talk about today is, although you're freed from space constraints with Dynamo, you do have to be mindful of time constraints. Water break. So, anyway, we're going to talk about one specific application we migrated, our site statistics application. This is pretty straightforward, very similar to statistics on other sites. People who are paying customers can come in, look at a page on the site, see how many times an image has been viewed, what their popular images are and whatnot. This is a straightforward log processing application. Data comes in, we generate a little chunk of JSON here that travels through our system. Eventually, it gets entered into the database. Eventually, users can come query it over time. So why would this make a good application for us to migrate? Well, so first of all, we had a control. We already had a working application that we understood well. I wrote that, so writing the next one made sense. It's a batch processing operation primarily. So I could control the flow of data. The reads are, it's not really the issue here. It's the flow of the writes. So it seemed like a good app. And also, I mean, this is an important application to SmugMug, but by no means is it the family jewels. It's something we could afford to screw up for a little while if we wanted to learn something. So once again, as an analytics system, anyone here who has done analytics understands, you've got this pipe of data, you've got the inflow, you've got the outflow to the user. That pipe, you have to make sure the outflow is at least some quanta greater than the inflow or the pipe backs up. And once again, you're accreting statistics over time as we were, and all of a sudden disks are filling up. What do we do with old data? Do we continue to make it available to users? It was obvious that these space concerns go away with Dynamo. I think that's the big sell for Dynamo, is that you can see it as an arbitrarily growable service. I was totally naive about the time constraints, though. So once again, the nice thing with this application was it was very simple, because it's very simple in the MySQL implementation. We just have IDs for users or images or albums. They're hash keys. The date's a range key. The data itself is simple. We only have a few tables, which is good, because more tables equals more bills in Dynamo. So one thing, though, I noticed immediately at looking at Dynamo, so our whole stack is focused on cache coherency in our caching system. And we're big users of multi-get in memcache, and we don't really, we sort of treat it as like an arbitrarily sized get that we can perform. I'm sure anyone who's looked at the Dynamo docs sees that the batch operations in Dynamo have a static upper limit. So if we were to take that static upper limit and push it all the way through our stack, now we have to change all of our PHP code to introduce this chunking at the intervals that Dynamo mandates. I knew immediately I wanted to abstract that out so that batch gets and batch writes would be arbitrarily sized. That means concurrency, and PHP doesn't do concurrency. So I started writing my own tools. A proxy, right, so a proxy that sits between code, in this case PHP, and Dynamo. So it's a long-running process. It handles all our credentialing. It handles concurrency, because PHP doesn't do concurrency. Why do we need concurrency? What do we care about concurrency? Well, since I've decided to make the decision to allow batch gets and batch writes to be arbitrarily sized, batch write 1,000, batch write 10,000, I need to have a system by which I can split those up, dispatch them concurrently, sew the results back together to go back into the rest of the code. So I wrote a proxy for that. And I wrote it in Go. So at this stage, about a year ago, I'm in a situation where I'm already in a little risk, and I'm digging myself deeper. I was working with Dynamo. That was an evolving system at the time. Go, also, the APIs were evolving. Nonetheless, I finally arrived on schedule with 2 code bases. These are the code bases that we're going to talk about a little bit later and will be free for you to use. One is called Go Dynamo. It is the equivalent of the AWS SDK Dynamo portion, but in Go. but it's not a rewrite of the AWS SDK. I never bothered reading the AWS SDK. It's a clean room implementation. And then BBPD is the HTTP proxy that wraps that talks to Dynamo. The name BBPD, like, good bin names are like good domain names. All the short ones are gone. So I had to use this. BB refers to the code name for Dynamo when it was being developed called Big Bird. I don't think that's a trade secret anymore, but so it's called BBPD. So now I'm going to start talking about just some of the observations I made when I was going through and developing and working with Dynamo, most of which I think are general enough that they're probably useful to other people. So once again, I mean, the obvious ones. You want to be denormalized. You want to have a sensible key mapping. You don't want to be reliant on complex querying because you're not going to have complex querying. This is fine because my assumption is most people using MySQL at scale are using this in a similar manner already. As Bjorn Strustrup says, avoid esoteric features in any tool you use. I definitely followed that in my development. I think if you do need esoteric features, my recommendation is just not to use Dynamo at all. Use one of the other AWS database services that give you SQL or MapReduce or whatnot. DynamoDB is not the tool if you need that. So I think this is the big one that's the key takeaway for developing with Dynamo and dealing with it, is to respect the throttling that Dynamo introduces into your work. Anyone who's used Dynamo has probably realized all of a sudden requests are slowing down and you don't know why, and you look at your error log and you see all these congestion reports asking you to retry your request. If you're using the SDK, it's all happening invisible behind the scenes, but there is a retry loop, and that is the throttling that the system imposes. Why does this exist? Well, think of what DynamoDB is. It's a shared service. It's on the WAN. And the protocol it's using really isn't that expressive, HTTP. You've got 200, your request worked, 500, Dynamo's down, or 400, you either have your request was malformed or something else. What is this something else? It's throttling. So this is all an observation now because Dynamo is opaque to us, so I only know what I observe. Throttling happens when the rate of increase of requests spikes. And if you go back and you correlate your provisioning to the rate of increase, you're probably going to notice that there's this big gap between what you've provisioned, your spike, but you're getting throttled anyway. And to me, at first I was scratching my head. I'm like, there's all this room between where I am, what I'm paying for, and I'm still getting told to come back in 500 milliseconds. What gives? It's about the rate of growth of your requests. So the one thing I would say is if you're seeing throttling in your application, I think the worst thing you can do is just go jack up your provisioning. You're just paying more, and you're going to get the same throttling anyway unless you change the way you work with DynamoDB. So what we can do here to attempt to minimize throttling is to optimize your requests over space and time. What does it even mean to optimize requests over space? Well, for example, let's say you've got 3 adjacent update item requests that you'd like to send off to Dynamo. Combine them into one. There, compression. You've gone from 3 to 1 request. Caching, obvious, right? So it's easier to read from Memcache than it is from DynamoDB. Reduce the number of requests, you're going to reduce those spikes. Hotkeys, kind of doable, probably not. I mean, hotkeys happen in applications. And I think this also brings us back into time optimizations. Also much harder to do, particularly if you're doing a live online application. You can't control when users come to your site. My situation was batch processing, so I can control the rate of flow through this pipeline. So I think the thing is here, you're going to see throttling. It's unavoidable as far as I can tell. You're just going to have to deal with it. Hotkeys, we all have hotkeys. Someone telling us to not have hotkeys is not actionable because there's always outliers in our data. So I think I would treat throttling as a necessary evil and a very strong warning. And if you keep seeing it, I think you need to go back and reassess how you've laid out your tables and how your application works. Now, the best way to do this is, from the get-go, use real data. Probably obvious to everyone here. Wasn't to me. So I started off working with test data because it was convenient. That test data didn't have the spikes, and it didn't have the shape of our real data. So lo and behold, as soon as I introduce real data into the stack, I'm seeing throttling. You know, once again, this comes back into what we keep saying. Use DynamoDB for what it is, not what you want it to be. Understand its key value store. Query and scan. If you think that they're the SQL equivalent, you'll probably be disappointed. DynamoDB is opaque, so we don't know what's going on behind the scenes. It's assumed to work, but we have this, all we have is the console. The console, if you've been to it, only has a little bit of information on it. So that means you're going to be iterating, as I was. So going back, let's try to put this in the context of some of our gripes with MySQL and see if Dynamo actually helped us here. So first one, the big one that impacted us the most is alter table. So DynamoDB doesn't have schemas. You're not going to be having any downtime to alter the schema. I'm going to give this one thumbs up and thumbs down because I think schemas are a good idea. They protect me from putting junk into the database. I haven't done so yet, but I probably will. The thumbs up part is that the database should be available all the time. So replication. Is it a success? Sure, thumbs up. I mean, we make a request to Dynamo and we get data back. I don't know or care if it's replicated or not. As long as I get the data back in the time they tell me they're going to give it back to me. It's opaque to the system, so I'll give it a thumbs up because it appears to work. Concurrency, thumbs up, thumbs down. So we're used to dealing with graceful degradation in systems analysis, and a lot of us know how to log into a Linux box and assess things with vmstat, iostat, whatever, and recognize graceful degradation when it's happening. Dynamo introduces this new kind of concurrency issue through throttling. The upside is it's limited to a table, whereas with MySQL, you maybe can expect to see full database degradation. So thumbs up in that it's limited to a table, thumbs down in that it's very hard to understand, especially if you are old like me and come from a background of assessing systems through graceful degradation. Ops, sure, yeah, they don't have to drive out to the colo at 3 in the morning anymore. They have to learn about DynamoDB, that's fine. Like many of you, our ops staff are already hip deep into AWS. They know the systems well. So learning one more system is not a huge thing for them. So now I'm going to spend a little bit of time talking about the tools I wrote and just a little bit of code. Why you care, once again, is because I'm giving them to you. First, once again, is a full SDK for Dynamo called Go Dynamo. It's written in Go. If you get one of the SDKs from the Amazon site that supports all of their services, this doesn't support all the services, it's just Dynamo-centric. And then BBPD is the proxy, once again, that sits on top of it and you can communicate with through HTTP. They're at github.com/smugmug. And they're all BSD licensed, BSD2. So once again, why do I want a proxy? So first of all, to go back, and once again, we had this issue where we wanted arbitrarily sized batch requests. So I need to be able to concurrently dispatch those to Dynamo and stitch them back together once they all came back. It moves that operation, and also it moves credentialing into a long-running, high-performance layer that sits between code and Dynamo. So it's nice for going into the command line and just sending off requests to Dynamo with curl. It also handles things like IAM credentials. The proxy can be running for weeks at a time. If you have a background process to refresh your IAM credentials, it will introduce them into the running process in a thread-safe manner. So because it's an HTTP proxy, I think a win here is any programming language that has an HTTP library, which is all of them, can now interoperate with Dynamo. You don't have to worry about someone making an SDK for you. This is very trivial. So this is showing you what you can do just with curl from the command line. The only thing noteworthy here is my only responsibility in playing with Dynamo using this tool is to properly format the request. There's none of the, if you've gone through and looked at the v4 authentication in Amazon, it's pretty complicated. I had to implement it. It took me a while. That's all hidden from you. You don't have to worry about any of the signing. Whether you're using the old style, access key secret pair, or IAM, this handles it all for you. All you have to worry about is properly formatting your request. So the neat thing here is this proxy is just a layer underneath these libraries that you can use in Go programs to natively talk to DynamoDB. Once again, IAM support, all the non-standard hacks I've put on top to make batch requests more fun. AWS v4 support. It's pro-concurrency and high performance. It lets me do some cool hacks. So one cool hack I did with this was I got rid of my normal HTTP proxy a while ago. And on our company trip, we had this hack day event. And I wrote another proxy that just did automatic backup. Every write request that came through, I just dispatched another thread to off in the background, write all the data to another table. What's the utility of it? I don't know, but it's something that I could do in a day because I had all of these libraries that were doing the heavy lifting for me. So why bother with Go, right? I mean, there's a lot of hype with Go, but is there more to it than hype, or is it just hype? So I've seen a lot of languages come and go over the years. And I realized a while ago what I needed was an actual checklist for a programming language, not whether just it's new, does it meet my requirements? So the requirements I came up with were strong types, concurrency, Unicode support, separate compilation, other nice-to-haves are fast startup, low memory use, batteries included, nice community. Go has all of those. Go also has a very nice deployment model in that you compile your code and you SCP it. That's it. So deploying is, you don't even really need a package manager for it. Furthermore, because Go is a modern language, doing things like taking your native structure and marshalling it or unmarshalling it to JSON is not an add-on. It's idiomatic and built into the language. So I think Go has a great future as an industrial language. It's easy to learn, and I think it's easy to sell your boss because it's got these checklist items. So now I'm going to go back. The example we looked at before that was doing a get item request from the command line, this is the same thing, but not with the HTTP proxy, just writing in Go code itself. So the first few lines you see here is launching a background thread, which is going to watch for my IAM credentials renewing. And when that happens, it's going to introduce them into the code base in a thread-safe manner. So all of my little Go routines, which Go parlance for threads, that are off running will always have proper credentials, even if the program is running for weeks at a time. The rest of it is just instantiating my get item type, populating a few variables, and dispatching it. This is the full program. So I think the one thing that's appealing to me here is the program is short. I think it's easy to understand. I think it's shorter than the equivalent Java, but has this pretty much the same performance characteristics. I think that's the big win that I see with Go is that it has the performance characteristics of something reminiscent of Java, but as you can tell, it has the syntactic characteristics of something reminiscent of Python. For me, that's a huge sweet spot. Last thing, I've been talking a bit about this automatic management of IAM credentials. When I was working on it, I realized that this is kind of something cool and neat that you could automatically have your IAM credentials introduced into code in a thread-safe manner. So I broke this out as its own library, which is, once again, free, BSD licensed on our site. And if anyone who's motivated, who wants to write other AWS code that has nothing to do with Dynamo, but uses IAM, might find it interesting. And that's just the beginning. You can go and take a look at the code. It's working for us. We're having fun with it. But like all open source, it will explode immediately and on impact with your environment. Your mileage may vary. We want to have pull requests, feedback, brickbats, whatever. We want to create a community around this tool and have a tool that everyone loves using. And that's it. Thanks a lot. Any questions?